All right, this is the retest review for the Algebra 1 PreAP class. All right, so first and foremost, problem number 1, we're going to simplify the expression, do not combine like terms yet. You've got to get rid of those parentheses here first thing. That's a most common mistake. Okay, so let's remember that if no number's in the front of a parentheses, we use a 1. So that's a 1, another 1. In this case, though, it's a negative 1. That's very important. So when we distribute here, it's just going to be 1x plus positive 9. Next one's going to be 7x minus 5. And the last one's going to be negative 1 times x squared, which is a negative 1x squared. But then this last one is where everybody misses it. Negative 1 times positive 3 is a negative 3. Now let's combine like terms. This number doesn't have a like term. It's just going to stay in the front, negative 1x squared. It has the highest degree. And now let's look at these numbers with x. We've got a positive 1x and a positive 7x. We're going to add these up and get a positive 8x. Okay? And then all the numbers I have left, positive 9, negative 5, and negative 3, are constants. We're just going to add them up. 9 minus 5 is 4, minus 3 is another positive 1. Now please stop here. Don't try and go any further. None of these are like terms, so there's nothing else we can do. That's as good as it gets. All right, so negative x squared, you don't need the 1. Some problems here. Negative x squared plus 8x plus 1. Okay, problem 2. A rectangular painting has a base of x to the 8th power, y to the 7th power, and a height of 9x, y to the 6th power. What is the area? You've even got the formula here which says area is base times height. So we're going to take our two expressions, 2x to the 8th, y to the 7th. We're going to multiply it times 9x, y to the 6th. Okay? Now this is a multiplication problem. So the 9 and the 2 and the 9 get multiplied like normal. We get 18, right? Now you guys, exponents are kind of strange, and they have their own special set of rules. So if I'm multiplying x times x on the bottom, something else is happening to their exponents. Let's remember there's a 1 here. So if I'm doing x times x, the exponents are actually not getting multiplying, they're getting added. So we're going to get an x to the power of 9. Okay, we're going to follow that same example and get y to the power of 7 plus 6, which is 13. So my area, my expression for my area in this case is going to be 18, x to the 9th, y to the 13th power. Okay? Problem 3. All right, what is the domain of this function? Remember guys, domain means x. So this question is asking us what are all the possible x values here. Something that I make my students do is to draw a boundary line around the edges of their function, of their graph. And it's always going to be a perfect rectangle, okay? Because now I can see, okay, the domain goes from here to here, right, left to right. And the range, even though we're not asking for it today, goes from bottom to top. Okay. Let's not forget this kind of symbol gets a less than or equal to sign. When the circle is open, it's just a less than sign. So we're asking for my domain. So I'm literally looking from the left side to the right side. So x's go from here to here. And in this case, they start when x is negative 1. They go all the way to when x is 4. So it's like we're literally saying all the x's are between negative 1 and 4. Okay? Now, on the left side, when x was negative 1, we have this open circle, so we got a less than sign here. When x is positive 4, it's closed, so we got less than or equal to. So my domain goes from negative 1 to positive 4, and make sure you're paying attention to those inequalities. All right, problem number 4, now we're looking for the range, right? So now we're actually looking from the bottom to the top. So here's my lowest point, here's my highest point. So from here to here is my range. Okay, well down here at the bottom, y is negative 6. up here at the top, notice I'm not looking at the end point. No, no, no. Right, bottom to top, lowest to the highest point, whether there's a dot or not. Go all the way up to 3, and it's range this time, so we're looking at y's. Now we've got to pay attention to our inequalities. Okay, here when y is -6, it's an open circle, so a less than sign. At the top, there's no circle at all, which means that we definitely want to use less than or equal to. Unless you actually see this open circle, go ahead and use this inequality. Okay, so that's my range. -6 is less than y is less than or equal to 3. Problem number 5, here we go. We're given an equation, f of x equals 1/2 times the quantity 4x plus 8, and says what is f of -3? So let me kind of lay this out for you guys. If I'm starting with f of x, and it's equal to 1/2 4x plus 8, and now I'm being asked about f of -3, can you see that x has become -3? That's what's happening on the right side as well, right? I don't have x anymore. Okay, I don't have x anymore. I have -3 in there, right? The x has become -3. So to answer this question, remember, because the left side's just notation, you're not really doing anything with the left side. Just take this, plug it in your calculator, right? If you want to do it by hand, you can, but I would still at least check it in my calculator, right? You have this fantastic tool for a reason. So we've got 1/2, and we've got parentheses times 4. We're definitely using parentheses when we substitute, right? That's best practice. And now we've got this plus 8. What do we get? We get -2. And that's our answer. All right. -2. Problem 6. Here we go. All right, in problem 6, we are looking at division. Okay, guys, we're looking at division. Now, some of you guys might remember how to simplify fractions. 3 divided by 18, divide both sides by 3. Both sides, I mean the top and the bottom, actually. 3 divided by 3 is 1. 16 divided by 3 is 6. So 1/6. By the way, if you're ever not sure, just want to check. If you do this in your calculator, 3 divided by 18, you get this decimal, right? But if you remember math enter, changes this to a fraction, and we can check that. Yeah, okay, that is 1/6. Right? We're just dividing because it's a division problem. Those are normal numbers. Then we get to our really super fun exponents. Okay, so we've got x to the 5th and x. Let's write a little 1 right here to help ourselves. The way that we like to do this is we like to say, okay, well, where is it bigger? Where do we have more? I definitely can see I have more on the top, right? X to the 5th is bigger than x to the 1st. So x is going to stay on the top. And then we like to say, okay, well, how much bigger is 5 than 1? It's bigger by 4. So that's my exponent. If you guys ever want to, if you're not sure, you can write this out, right? X to the 5th is this. X to the 1st power looks like this. If you were to cancel, that's all you would do. So you'd be left with x to the 4th. Okay, that's another way to think about it. Okay, let's go ahead and let's look at our y's. Here we go. We got y to the 3rd. Y to the 7th means it's bigger on the bottom by how many? By 4. The z to the 0 power is just a 1, right? Anything to the 0 power is 1. Don't write it. That's our answer. I'm not going to write the 1 though. So we're going to have x to the 4th power over 6y to the 4th. Okay, flip it over. Let's look at the back. Does the following graph represent y as a function of x? Yes. Remember, guys, if it's a graph, we can use the vertical line test. None of these vertical lines are hitting more than once, so we're good to go. So we're going to say passes vertical line test. Problem 8. Here we go. Make a graph and a mapping using this table and list the domain and range. All right, here we go. We're going to go ahead and we're going to do -3, 4. -3, 4 goes right here. Okay, then we're going to do -2, 6. Sorry, -2, -6. Just going to go right here. All right, next we're going to go 0, 3, which is this point here. And now we've got 3, 1 over 3 up 1. There we go. Okay, my next point is going to be 3, negative 4. So over 3 down 4. And my last point is going to be 4, 5 over 4 up 5. Okay. Now let's look at the mapping. Don't forget the mapping, guys. We're going to go least to greatest. We can look at the table here and just go ahead and put it in the same order. It's already in order here. So we've got negative 3, negative 2, 0, 3, 4. Notice I did not write the 3's twice. Let's go ahead and let's do the range. Do from least to greatest though. Be careful. So we've got a negative 6 and then a negative 4. And then we jump to a 1 and then a 3 and a 4 and a 5. Okay. Now draw your arrows. Alright, so 3 goes to 4. Positive 4. Okay. Negative 2 goes to negative 6. Okay. Let's see here. 0 goes to 3. Alright. Then we got 3 going to 1. And then we've got 3 going to negative 4. And last but not least, we've got 4 going to 5. Okay, our domain and range this time, because we just have dots, we're going to make a list. Alright, we're going to make a list. I like to look at the mapping once I have it because they're already going from least to greatest. So negative 3, negative 2, 0, 3, 4. Then my range is negative 6, negative 4, 1, 3, 4, 5. Okay. Now you guys remember this time we made a list because we could. In the last domain and range problem, it was impossible to make a list, so we didn't worry about it. Okay? All right. Write the expression in radical form, problem number 9. Okay, in this problem, let's first remember that this is really 4 times x to the 1/2. We have a special rule for stuff like this. If you guys look on your formula card, it says a to the m over n equals, n's in the index number right there, a to the m. We're just going to follow that same exact pattern, all right? So we've got x on the inside, the 2 goes in this spot, and the 1 goes in this spot. So we've got 4, and then let's recall that if a 2 is here, we don't really need it. Right? The index is default a 2. That's what we usually call as a square root. And if the exponent is 1, again, we don't really need an exponent of 1. So in this case, our final answer can be simplified as 4 square root of x. Okay, last but not least, problem 10. This graph shows Sally's trip from home and back to pick up her kids. Describe what happened between 3 and 6 minutes. All right, well, since this is time, I know you can't really see that, and this is distance. So if time is passing, but her distance is not changing, what's she doing? One more time. Time is passing, but her distance from home remains the same. Guys, that has to mean that she stopped. All right, so if she's driving, maybe she hit a stoplight? No. Not in this case, because it looks like she drove, she stopped, she came home. So this must be when she stopped picking up her kids. So I'm going to say stopped and picked up kids. All right, that's got to be what she's doing during that time. She's not moving, and then she turns around and goes home. She must have stopped and picked up her kids. Okay, that's the end of this review. Please remember that your retake is very, very similar to this. So if you can do these problems alone confidently, you should be good for your retake. Don't forget the deadline for that is this week, right? Ends on Friday. Good luck.